Okay, statistics and precalculus, looking at odd and even functions. This is lesson 5.1. It's mentioned in there. How to tell if a function is odd, even, or neither. There are lots of odd numbers in the world, as you know. There are also lots of even numbers in the world, but most numbers are neither. Neither odd nor even. Things like 3.7. It's between 3 and 4. It's not odd or even. Similarly, there are many odd functions in the world, and there are many even functions in the world. But most functions are neither odd nor even. Lots of different varieties. How to tell graphically. An even function is symmetric over the y-axis. You have a point here. It's going to correspond with the point there. They are going to be symmetric. An odd function, on the other hand, is symmetric over the origin, or a 180-degree rotation about the origin. If you take a point like that one, and you rotate it down here, it'll be the same point on the opposite side of the origin. So you can tell graphically, again, an even function is symmetric over the y-axis, an odd function is symmetric over the origin. Many functions are neither. For instance, x squared plus 5x minus 2 is symmetric over the line x equals negative 2.5. That's not over the y-axis, that's not over the origin. It has a different kind of symmetry. Or the graph of g of x is 5 to the x power, has no symmetry. So there we go. Graphically, if it's an even function, it's symmetric over the y-axis. If it's an odd function, it's symmetric over the origin, which is the same as a 180-degree rotation. And if it's neither, it will have some other kind of symmetry. Numerically, you can tell because any given point on the graph, like this is y equals x squared, so for instance, you know the point 2, 4 is on the graph. You will also find the point negative 2, 4. That works on both sides. If you started with point 3, 9, you would also find the point, if you started with negative 3, 9, you would also find the point 3, 9 on this side. So, if x, y is on the graph of an even function, the opposite of x and y will also be on the graph. If it's an odd function, they're both opposite. For instance, y equals x cubed has the point 2, 8. Because it's an odd function, it also has the point negative 2, negative 8, where you're looking at the opposite of both. Or for instance, you have negative 1 here, and 1, 1. The opposite of both. If it's an odd function, the opposite of both will be on the graph. Numerically, you can't tell if you just look at one point, you see what others are not there. To know for sure, you can't just use one point. You have to go algebraically. Algebraically, you find and simplify the function at a negative value of x. So here's x squared plus 5. F of negative x is negative x squared plus 5. But negative x, when you square it, is the same as x squared. So this is x squared plus 5. You have that f of negative x is exactly the same as f of x, which is because of the symmetry across the y-axis. If you put in a negative value for x, you'll get the same as if you put in the positive value if you picture your parabola. An odd function, algebraically, if you put in the opposite of x, negative x cubed plus 5 times negative x, you will get the opposite of x cubed minus 5x. And you'll notice that is exactly the same as the opposite of f of x. This is your symmetry across the origin. When you put in the opposite value for x, you get the opposite value for y. If it's neither, you'll get something else entirely. Like if I put in my opposite of x plus 5 times the opposite of x minus 2, I would get out the opposite of x squared is going to be the same as x squared. This will be minus 5x. This will be minus 2. You'll notice that is not the same as f of x. It's also not, because of the minus on the f of x, it's also not the same as the opposite of f of x. So this function is neither even nor odd. So there you have it, the graphical, the numerical, and the algebraic ways of finding if a function is odd or even.